So this little video is dedicated to Miss Ashley Mallon, who said, Mr. Milbrath, don't record anything, so I'll have to do stuff over Christmas break. You're welcome. This is for you. This is number 60. The sides of an acute triangle measure 14, 18, and 20 centimeters respectively, which of the following equations, when solved for theta, gives the measure of the smallest angle of a triangle. So it's a theorem. There's two of them you can use. It doesn't actually matter which one you use. But they're giving you two theorems here. They're giving you what's called law of sines, which is a geometry standard. And then they're giving you the law of cosines. So the triangle that they describe has side lengths only. It's all they give you. It's called ABC. Do it the way I show you. And it doesn't really matter where you put the lengths because they don't tell you what's what. But I'm seeing a 14, an 18, and a 20, and you'll notice I still go around my clock because that's just what I do. Law of sines requires either two angles and one side or two sides and one angle. So two angles and one opposite side, or two sides and one opposite angle. And you could tell, like if I set up law of sines, which says sine of A is to A and so forth, if I tried doing law of sines, I would have sine of A is to 18, because little a is opposite of big A, as sine of B is to 20. And this has two unknowns. You can't solve anything with two unknowns. So it's got to be law of cosines. Need a little more room here. And they're nice enough to give you law of cosines. Law of cosines is actually the original Pythagorean theorem. Pythagorean theorem only applies to right triangles. Law of cosines applies to all. And while we as a species discovered Pythagorean theorem first, it wasn't until quite a bit later that we discovered the true situation. So that's why it looks like Pythagorean theorem. Pythagorean theorem is a small subset of all triangles. Anyways, that's just a history lesson. So I'm going to do law of cosines, and they want us to solve for which of the following involved for theta gives the measure of the smallest angle of the triangle. So actually you have to know hinge theorem too. Small angle, small side. That's hinge theorem from geometry. This is the smallest angle. It's opposite of the smallest side. The way I drew it anyways. But anyways, everything will take care of itself. So I actually legit get to use the law of cosines as it's written. That little c squared, which is 14, must equal a squared plus b squared, the other two sides, 18 squared plus 20 squared, minus 2 times 18 times 20, because a and b are the other sides, times the cosine, and they call it theta. The cosine of theta. So it's actually a really easy problem. It's that one right there. If you know law of cosines, you actually don't have to do any work. Like none of what I drew. But I don't know that y'all know law of cosines. I don't know if your geometry teacher did it with you or not. You'll have to ask her. Isabel, you could ask her. If you don't remember law of cosines, ask your mom. I just don't know if they did it with you. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 answers, only one of which is correct. If Elliot randomly and independently answers each question, there's a probability he'll get each of the 4 questions correctly. So the odds of getting a question right are 1 in 3. Multiple choice, 1 in 3. The odds of getting 2 right by guessing would be 1 in 3 times 1 in 3. The odds of getting 4 correctly would be 1 in 3 times 1 in 3 times 1 in 3 times 1 in 3. This is the odds of guessing and getting all 4 correctly. It's a counting theorem. I don't know, it's a name. Anyways, it's 1 over 3 to the 4th, which obviously choice E. That's 3 times 3 times 3 times 3. This is a dumb question. It really is a dumb question. A lot of kids would miss it. So when I defined absolute value for you guys in Algebra 2, I told you absolute value is the distance from 0. Now the odds of you actually remembering that when you take the ACT are slim to none. You will actually have a TI-84 in front of you. Well, if you understand this definition, then you know the answer already. Maybe, I don't know. There's some notation that I don't use with y'all that maybe I should. You suck at notation. But anyways, x minus 5, negative 1. This will be saying where is the v below negative 1. And the v is not going to be below negative 1 because the v can't be below negative 1. If it was a negative v, you'd be in business. There's no answer. You can look at the graph and you can tell there's no answer. So hopefully you can kind of imply that that's what this means. Empty set. That means, literally means no solution. All right, moving on to 57. That looks like a sine function, maybe a cosine function. It says the functions y equals sine of x and y equals sines of x plus a plus b. You know, I used to teach this in Algebra 2. I haven't had a group I could do that with in a minute. Anyways, y is sine of x and y is sine of x plus a plus b for the constants a and b are graphed in the standard xy coordinate plane. Boy, that's a wall of text. The functions have the same maximum value. One of the following statements about the values of a and b is true. Which statement is it? Well, based on what y'all know already, and you actually know some, you guys, my high achievers anyways, maybe not even my high achievers, a lot of y'all in the middle know this. X plus 2 squared, actually let's talk about x squared first. X squared looks like this. That's x squared. X plus 2 squared looks like that because of the shift left that's happening. The plus 2 is shifting the graph left 2 units. So something has happened. So one of these is sine of x, and the other one is sine of x plus a plus b. Well, so extend upon this. What if I did x plus 2 squared plus 3? Well, that would take this guy and move him up 3. Now he'd be there. What I can tell you by looking at this thing is that there was no shift up. So that b has to be 0. Ta-da! Just like that. All you had to realize was you weren't shifting. Makes it choice A. All right, the square below is divided into 3 rows of equal area. In the top row, the region labeled A has the same area as the region labeled B. In the middle row, the 3 regions have equal areas. In the bottom row, the 4 regions have equal areas. What fraction of the square's area is in a region labeled A? What's the easiest way to do this? So we need to know all the A's, right? The easiest thing to do is probably to come up with good numbers for your square. I'm kind of thinking 12 works. Make the thing a 12 by 12. So if it's a 12 by 12 square, the area of the square would be 144 units. And I use 12 and 12 just because I can make this a 4, that a 4, that a 4. So each one of these regions would have an area of 48. Now this, I wish I had more room to write. And you're probably listening to me muted. But if this is 4, 4 times 12 is 48. Those are 24, 24. If this is 4, 4 times 12 is 48. 16, 16, 16. If this is 4, this is 48, which means each piece is 12, 12, and 12. If I take my A's and I add them together, I'm at 52. So the area of the A's is 52 pieces of 144, which ought to reduce. It's 26 over 72, which is going to be 13 over 36. Yeah? Yeah. 13 over 36. By the way, you're an absolute moron if you pick J. Like, what's wrong with you? How many times you get dropped on your head? Go talk to your mom. She did something to you. Was she on meth? Something's wrong with you. And if you don't understand that, something's really wrong with you. Don't pick J. Don't do it. All right, last one I'm going to do in this video. If I get up here early tomorrow, I might do another one. I might stay after tomorrow just to ruin Ashley's Christmas break, because that's how I is. All right, so we have a poll in front of us. Kelly asked 120 students questions about skiing. The results of the poll are shown in the table below. Have you skied either skied? What's a skied? Anyways, cross country or downhill? If you answered yes to question 1, did you ski downhill? If you answered yes to question 1, did you ski cross country? After completing the poll, Kelly wondered how many of the students polled had skied both cross country and downhill. Oh, I hate these. How many of the students polled indicated they had skied both cross country and downhill? Can't even talk. This looks like it needs a Venn diagram. So, I'm going to pause, come back, because I got to think about this. Those bother me. There might be a formula I can use too, but off the top of my head, I don't have it in my head right now. So I need a few seconds instead of me staring at this thing looking stupid. So I'll start here next time.